In today's lesson, Chapter 2, Section 3, we're going to talk about using postulates and diagrams. So the strategy here is to understand the postulates that I'm going to list, understand what they might look like in a diagram, and how I might describe them. Don't worry so much about the number. Remember that the number just means that this is in chapter 2 and it's the first one, chapter 2 the second one, chapter 2 the third one. But unfortunately there's not a universal set of numbers, and so we ignore the numbers. So I would either worry about the titles of them, and I would definitely worry about what they mean or what they say. So in the first one, let's start with number 1 here. We've got the 2-point postulate. The 2-point postulate says that through any 2 points, there is exactly one line. So if I have point A and point B, I can only draw one line through those 2 points. One and only one line through them. The second postulate is called the line point postulate, and it says that a line contains at least 2 points. So I know that if I have a line, I have at least 2 points on that line. I know I'm going to have an infinite set, really, but I have to have at least 2 points to create a line. Okay, so this one really talks about the minimum number of points needed to create a line. So this one really talks about minimum number, and I know I'm going to need at least 2. The third one is called the line intersection postulate, and it basically says that if I have 2 lines that intersect, then their intersection is exactly 1 point. So here's one line, let's call it line A. Here's line B, and line A and B, as you can see, intersects in 1 point. This is the intersection of 2 lines. So it's an intersection point. And the fourth one on this page says the 3-point postulate. It says that through any 3 non-collinear points, there is exactly 1 plane. And so this is very similar to the 2-point postulate that talks about through any 2 points, there's exactly 1 line. This says through any 3 points, there's exactly 1 plane. And so again, here you have point A, point B, and point C, and all of those points are in this particular plane. Anytime you have 3 non-collinear points, they are very unique to 1 plane and 1 plane only. When I come here to the next one, plane point postulate, this is number 5. This says that a plane contains at least 3 non-collinear points. Again, this is the minimum number of points to create a plane. Okay, this is similar to the line point postulate that told you that you needed at least 2 points for a line. So again here, this is saying you need at least 3 non-collinear points for a plane. And number 6, remember these numbers, these numbers here don't matter, but the 6th postulate we're going to cover is the plane line postulate. And again, this says that if 2 points are in a plane, then the line that contains them is in the plane. So here you have a plane, here you have point A, and here you have point B. Well, if I happen to draw a line through those points, the line is also in the plane. So the line between A and B is the same plane as the actual points themselves. And the last postulate we're going to talk about today is the 7th postulate of the day, and it is the plane intersection postulate. And this basically says that if 2 planes intersect, then their intersection is a line. So think of this plane here, and then think about another plane drawn from that intersects this, like maybe a plane that goes, this goes behind it, this doesn't. And so you have these two planes, and you notice that the two planes are going to intersect at this line. Now it looks like it's a line segment, like it starts and stops, but remember that planes are really boundless. And so I know that these planes are going to go in every direction. So I know that the intersection is not going to be a segment, but rather a line itself, an infinite line. So another interesting thing here is about perpendicular figures. Now perpendicular figures intersect or meet at 90 degrees, which is a right angle. Okay, so a line is perpendicular to a plane if and only if, no, this is a biconditional, the line intersects the plane in a point. So the line intersects the plane in a point and is perpendicular to every line on the plane that intersects that point. So let's look at this image. What this image is telling us here is we have line P, and we have line Q, and we have line T. And in these three lines all meet here at this common intersection point. And so, again, a line is perpendicular to the plane. This line T is perpendicular to plane A. If and only if it intersects the plane in a point, which it does, it intersects the plane in a point, and is perpendicular to every line in the plane that intersects at that point. Notice it's perpendicular to line Q. Notice that this is telling me it's perpendicular to line Q. And if it's perpendicular to the other line P, and this one here tells me it's perpendicular to line P. So it meets the criteria for being perpendicular to the plane and the lines in it. Now we're going to apply what we've learned, and we're going to try to state the postulate illustrated by the diagram. And again, this is where, yes, I would like you to know the names of these postulates. However, if you can at least tell me what the postulates say, I would be pretty okay with that. So notice that you have this if-then statement. You have if, and you have two intersecting lines, and then you notice that it mentions in the then part, it has the point at which they intersect. So I know that this is referring to the line intersection postulate. And what this is saying is if two lines intersect, then they intersect at a point. Then they intersect in exactly one point. Or something to that effect, right? It's just basically saying, again, that two lines intersect in a point, and that's what that picture's showing me, okay? The next one, it's talking about two planes, and it basically says you start out, if you have two planes, then, and notice this, what it's showing you that they intersect in a line, right? So this is the plane intersection postulate, okay? And this is talking about if two planes intersect, right, then they intersect in a line. Here they want me to use the diagram to write examples of the plane point postulate and the plane line postulate. Now again, I need to know what these postulates are to be able to come up with an example. So the plane point postulate tells us that a plane contains at least three non-collinear points. So a plane contains at least three non-collinear points. So when I look here, I'm going to look at what's been given to me. And I notice that what I've been given is plane Q, And plane Q doesn't really have a lot of points on it. The only point that's on plane Q is A. So I don't have enough information here to actually name this point or identify 3 non-collinear points. However, plane P is a little bit of a different story. Plane P has point B, point A, so it has this line, and it has point C on the plane. So how would I show an example of the plane point postulate? Is if I said something like plane P contains, right, B, A, and C. Then I go to the next one, which is the plane line postulate. And what this one says is that 2 planes intersect in a line. Intersect in a line. And so when I look at this picture, I recognize that plane Q and plane P intersect at line M. And that's what the thing is just telling me, that 2 planes intersect in a line, and a plane contains 3 non-collinear points. So that's how I show both of those. Here we talk about which of the following statements cannot be assumed from the diagram, and here I have to be very careful. A, B, and F are collinear. So when I come over to here, I see that A, B, and F are all on this line that was drawn in here. So this is a true statement and a true assumption. Nothing wrong with assuming that those 3 points are on a line. In fact, they absolutely are. The second assumption says that points E, B, and D are collinear. So here's E, here's B, and here's D. Now, while I think that this probably is in a straight line, right? I definitely would like to think so. Unfortunately, I have to know for sure that they're on the same line, so I've got to see the line. Okay, notice that ABF is definitely a line. ABD, I'm not sure. And so, unfortunately, I cannot assume that those things are collinear. And AB is perpendicular to S. Again, I cannot assume that line AB is perpendicular to S, because remember that line AB has to be perpendicular to S if it is 90 degrees to F, but if it's also 90 degrees to its other side lengths or lengths. And so I would have to prove that it's perpendicular to BC before I can say that it's perpendicular to the plane or whatever. All right, so this is a false. CD, the same thing goes for CD, okay? And CD, it says CD is perpendicular plane T. So this line here is perpendicular. And again, nothing really tells me that there is any type of right angle here. And so I'm going to say this is a false. And the last one on this page is AF intersects BC at point D. So AF intercepts BC at point P. And so yes, this is the intersection line. And lastly, this kind of takes us back to our vertical angles and supplementary angles. Just a refresher. Remember that a pair of supplementary angles have a sum of 180 degrees, okay? So, and then a pair of vertical angles, well, let's see. So vertical angles are easy. It's this angle and this angle. Now, writing it might be a challenge. So one pair is going to be PWT, angle PWT, and angle VWQ. So that is definitely an option. The other option relates to this one. And so again here, the second solution here would be angle TWQ and angle VWP. So those are the two examples of vertical angles that I can give you. The supplementary angles, that's next. So two pairs of supplementary angle. Remember that everything that forms a straight line is a linear pair if it has two angles that form that straight line. And of course they're adjacent. So it meets all the criteria of supplementary angles or linear pairs. And so again, how do I describe those? Well, let's call this angle 1 and angle 2, right? So I know that angle 1 is going to be TWP, and angle 2 is going to equal PWV. So that's my first